This is section 1.04 from Unit 1, Part 1, Measures of Spread 5-number summary. Today I am, as in you are the student, using tools to calculate measures of spread so that I can find the 5-number summary, range, and interquartile range of a data set. I will know I have it when I can read and interpret a box plot. Specific TEKs we're looking at for this lesson is 9B. Quartiles. We're going to be looking at a data set, and from that data set, we want to split it into 4 different quarters. And quartiles is what allows us to do that. So with the first quarter, we have a data set, and then the first quartile splits that data into a quarter. And then we move on to the second quarter, and then the second quartile, which again splits it into another quarter. Second quartile can also be called the median. Third quartile, and then third quarter, and then third quartile. And then fourth quarter, and then we don't typically have a fourth quartile. Okay, these quartiles are typically used for sales, for basically looking at data in a different way to understand the distribution of data. We're going to be looking a little bit at box and whiskers plot, and what the box and whiskers plot does in terms of quartiles allows us to see the spread of data. Basically, where's this data located on the number line? Is it more towards to the left? Is it more towards to the right of the number line? Is it centered on the specific number line that we're looking at? What are the low, high values of it, etc., etc.? Just another way of analyzing data to maybe reveal something to us that wouldn't be revealed if we only saw this list of data. Okay, so we're going to find something called a 5-number summary, which again will show us the spread of data. So from this 5-number summary, we have 5 different things we're going to be looking at. Minimum value, which is the lowest or smallest value. First quartile, which is the median of the first half. The median or second quartile, which is the middle value of the entire data set. Third quartile, which is the median of the second half of the data, and then the maximum value, which is the biggest or largest value. So we're going to be finding medians upon medians upon medians. This 5-number summary is based off of finding those medians. Okay. So again, this box and whiskers plot shows us the distribution of data. Notice how the middle half of that data is distributed towards the right of this box and whiskers plot. Notice this first whisker right here is elongated, gets into the box, and then we have a short whisker on the right side, which again kind of tells us that the middle half of the data is skewing towards the upper part of that section. And then you can see more distribution of the data. The third quarter, notice how the third quarter has a larger box than the second quarter right here. And again, notice how the first quarter has a bigger whisker compared to the fourth quarter right there. So all that stuff just to show us how the distribution of data is happening to the data set. Let's look at an example. So how do we apply this to a data set? I'm going to cover some of these things up, and then we will reveal them as we go. All right, so for this example, I have a data set. 11, 13, 26, 28, 28, 29, 30, 31, 33, 37, 37. From this data set, I want to find a 5-number summary. Okay, so this 5-number summary, first thing we have to do, step 1, is to make sure we order the numbers from smallest to largest. Now, for the sake of this example, it's already been done, but you would go through the list one by one and put them in order from least to greatest, which we've done right there. Excuse me. Now, step 2, identify the minimum and the maximum, the smallest and the largest. If you do this in order, it's easy to identify. So the smallest is all the way to the left, the minimum, which is 11. The maximum is all the way to the right, which is 37. So there's our minimum and maximum values. Now, median, Q2, second quartile, you would take your list and try to move your way down to the middle. So you're eliminating numbers left and right until you're left with 1. So left and right is 1 round, and then you would go a second round doing it again. Left, right. Let's go a third round. Fourth round, left, right, until you're left with 1. And so in the case of this example, our median is 29. Right there. Now, from the median, I'll just use what I have right here up top. From the median, we need to find the first and third quartile. So starting with the first quartile. To find Q1, we're going to find the median of the values that are less than the median. So our actual median is 29. I'll use this one right here. So we're going to use the first half of numbers, not including the median, and then find the median from there. So again, do the whole left-right elimination process. Left, right, until we get down to one number, 26. So 26 is our Q1. And again, notice for this example right here, 29 is not included in finding the median of the first half of data. And now we're going to do the exact same thing for the third quartile, except we're using the upper half of data. So again, eliminate numbers left, right, until we get to a middle number. And so Q3 becomes 33. And now we're going to put all that information together. So we're going to use the minimum, maximum, the median, Q1, Q3. We're going to compile that all together to describe the 5-number summary of this data set. Okay? And so the minimum all the way up to max, Q1, Q2, Q3. But Q2 is median, by the way. This is my final answer to what is the 5-number summary of this data set. Now to show you a box and whiskers plot. This is extra, but I thought it would be good to show y'all box and whiskers plot. So I'm going to count these. Let's see, my minimum is 11, so let's start at 10. So we'll start at 10, and we'll count by 5s. So this is 15, 20, 25, 30, 35, 40. Okay? So my minimum is 11. So I'm going to go like right above the 10, right there. My Q1 starts at 26. So right here is where the box would be, Q1. Q2 is 29, so it's right before the 30, right there. Q3 is at 33, so it's a little bit above the midpoint right here. And then we have the max, which is about 37, which is right here. Now, putting that all together for my box and whiskers plot, it's a little bit crude, but y'all get the idea. Notice how the middle half of the data is more towards the right side of this number line. Notice how long this first quarter is. This first quarter has a bigger spread compared to the fourth quarter. Notice how it's very slight, but Q3, which is right here, is slightly bigger than Q1. They could be the same size, actually. I think their Q3 is bigger, though. But the spread of data for Q3 is bigger than Q2, and so on and so forth. So it shows us where things are spread out on the number line to then analyze and deduce conclusions and maybe figure out what's going on with the data set. All right. So again, that's just bonus to kind of understand what the point of 5-number summary is, box and whiskers plot. So now, anyways, continuing on, here is the U-try. So for this U-try, I want you to find the 5-number summary of this boxed-in data set. Step 1, order the numbers from smallest to largest, and just make sure to use commas to separate each of the numbers. Step 2, find the minimum and maximum values. Step 3, find the median. And I've given y'all a hint, and for a specific reason. Odd amount in the list is middle number is median. If you have an odd amount of numbers in the list, I should say, then you'll only have one median. However, if there are even amount of median numbers, you will have 2 numbers to deal with. But to get the median, you need to take the average of those 2 numbers. Okay, so I'll go over that in a bit if y'all don't understand. But that's step 3. Step 4, find the Q1. To find the Q1, you're going to find the median of the values that are less than the median, meaning the lower half of that data. You're going to find the median of that. And then for Q3, you're going to look at the upper half of that data. Do not include the median when finding that. And then compile all of your numbers and then put them here in this box to get your final 5-number summary answer. Okay, so right now I would like for y'all to pause the video, try this on your own. If you are logged in ClassKick, go through it, check your answers on the next page by moving these boxes to see if they are correct. Otherwise, I'm going to continue on and show y'all how to do U-try number 1. Okay, starting with the first step, ordering the numbers from smallest to largest. So taking the data, putting it in order, you get 2, 3, 3, 5, 8, 9, 9, 12, 13, 13. Notice how I put everything in order, including the repeated numbers. Don't exclude the repeating numbers. Make sure you put everything that's listed in order from least to greatest. Then from there, you can just simply find the minimum and maximum values by looking at the left number and right number. Left number is the minimum, which is 2. Right number is the maximum, which is 13. Now to find the median, we're going to go through our elimination process by crossing out the left, right, and then continuing until we get to a number. Left, right, left, right, left, right, left, right, and oh no, I've crossed out all the numbers. There doesn't seem to be a median. If that ever happens, though, you're going to take it one step back. And this is what I was talking about. If you're left with 2 different numbers, if you have an even amount of numbers, you're going to be left with 2 different ones. You're going to take the average of those 2 numbers, and that will be your median. What do I mean by that? So you're going to add them up. 8 plus 9 equals 17. 17 divided by 2 is 8.5. 8.5 is our median, aka the Q2 of the data set. And that's it for step 3. All right, now that we know 8.5 is Q2, so I'm going to write it right here. That is 8.5 Q2. We're now going to find Q1 and Q3. Q1 focuses on the first half of the data set, not including the median. And then we find the median from there. So left, right, median is 3. So this would be considered our Q1. Then just to show you right here, nope, that's not it. Should be right there. To find Q1, find the median of the values that are less than the median, meaning the first half, which is 3 in this case. For Q3, we look at the upper half. Do it again. Left, right, until we get the median of that upper half, which is 12. And that will be our Q3, as you can see right there. Now, take all this information. Take everything that we found and compile it into a 5-number summary. Minimum 2, Q1 3, Q2 8.5, Q3 12, max 13, and that's our final answer, the 5-number summary. And if y'all are curious about the number line, let's count by 2s in this case. 2, 4, 6, 8, 10, 12, 14. So we have a minimum of 2. We'll say this is 0. This is 16. Q1 is right at 3, which is right here. Q2 is 8.5, so that would be about right there. Q3 is 12, right there. And then 13 is right there. So our box and whiskers plot for the data set. Sorry for the scribbles, but basically shows us we got a wide middle right there. A wide middle that encompasses a large swath of numbers between these two numbers, between the minimum and the maximum. Notice how the whiskers are very short and the boxes are big. Could tell us something if we analyze it further, but just an interesting little viewpoint of our data. All right, and that's it for you. Try number 1. Let's talk about range. The range basically is asking for what is the span of numbers that we're dealing with for our data set. Okay, so how many numbers are we, what is the range, what is the distance from the minimum to the maximum? That's what range is talking about. Excuse me. So to find the range, we take the maximum value, subtract the minimum value. This example, the same data set that we had from before. What is the range of the data set? First things first is you always put the numbers in order from least to greatest. From there, find the minimum, find the maximum. In this case, it's already in order, so we're not going to worry too much about that. But the minimum is 11. The maximum is 37. So 37 minus 11, max minus min, is equal to 26. And just to show you on the calculator, 37 minus 11, 26. And then there is your range. You try number 2. What is the range of the data set? So order the numbers from smallest to largest. Use the commas to separate each number. Use this formula to enter the max and min, and then get your final answer. Okay, move this box if you want to check your work after you've attempted it. So at this moment, I would like for y'all to pause the video and try this on your own. Otherwise, we're going to continue on and show you how to do this. So step 1, order the numbers from smallest to largest, starting with 2, then 3, we have that twice, then 5, 8, 9 happens twice. And then we have 12 and 2 13s. Okay, now what is the min? What is the max? Minimum is 12. Max is 13. So subtract those two. 13 minus 2 is 11. So my range of data, the distance from one endpoint to the other, the minimum and the maximum, is 11. So it's got a short range, short span of numbers on a number line, basically. Okay, and then there's the work just to show you that everything's good. And that's it. That's it for range. Interquartile range. So range is from minimum to maximum. Interquartile range is from Q1 to Q3. So this basically tells me the span of the box from the box and whiskers plot. It'll show me how the spread or the distance of data from Q1 to Q3 for the box. So this interquartile range is also talking about the middle 50% of data in a data set. So anytime I ask you for the interquartile range, I'm asking for the middle 50% of the data. The box portion is considered the middle 50%, since each one is broken up into quarters. All right, here are the steps. So we're going to calculate the interquartile range. First, we're going to order the numbers from smallest to largest, find the median, find Q1, then Q3, and then the last step is to subtract Q3 from Q1. So let's look at an example. So I'm using a previous example that we've done to go through it all. No, I'm sorry. It's not a previous example. It looks like it's a different one. So step 1, we're going to order the numbers from smallest to largest. So just to show y'all what that answer is, our original data set turns into 6, 6, 16, 19, 20, 20, 20, 21, 22, 25, 26, and 30. Okay, now we need to find the median of this data set. So start doing our elimination process. Left, right, until we get to the middle. Median is 20. Now, from the median, we find Q1. So that's the first half. So from Q1, left, right, Q1 is 16. From the upper half, again, not including the median, left, right, Q3 is 25. Right there. And then from here, we take Q3 and subtract Q1. So that's 25 minus 16, which gives us an interquartile range of 9. And that's our final answer. Basically, the span of numbers for the middle 50% is 9, the distance, which is a short distance. Okay, you tried number 3, interquartile range. What is the interquartile range of the data set? So take this data, order them from smallest to largest, find the median, then find Q1 and Q3. After you find those two, subtract them, and then you will get your interquartile range, your final answer. Move the box if you want to check your answers as you go, or if you need a hint as to how to do them. Try this on your own. Otherwise, I'm going to go ahead and show you how to do this problem. So, first, Order the numbers from smallest to largest. So starting with 1, let me use a different color here. Starting with 1, and then next up is 2, 3, then we have 6, we have 3 sevens, we then have 8, and we have 9. Okay, from this list, we want to try to find the median. So, do the whole left-right thing. So left, right, left, right, left, right, left, right. All right, we got a middle number. And you can also know ahead of time we're going to have a middle number by counting how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have an odd amount, and so we do have a middle number. If that were an even amount, we would have to take the average. Anyways, the median is 7. Okay, now from that list, to find Q1, we're going to take the upper, or the first half of numbers. So 1, 6. We got 2 medians here, so that means we're going to have to take the average and divide by 2. Add them all up and divide by 2. So 2 plus 3 divide by 2. Our median for Q1 is 2.5. Okay, we're going to do the same thing with this upper half. Again, we don't include the 7. So 7, 9, same thing happened. We're going to add those 2 up. 7 plus 8, divide that by 2. And we have 7.5 for the median, the Q3. So 7.5. Now, to find the interquartile range, we're going to take Q3 and subtract Q1 from it. So 7.5 minus 2.5. If you want, plug that into the calculator. I believe that's 5. 7.5 minus 2.5. And we get 5. And that is our final answer. Now let's check behind the box, make sure we're doing this correctly. And we are. Q1 should have been 2.5, which we got. Q3 should have been 7.5. Subtract the 2, and we get 5. Okay, and that's it for you try number 3. Okay, now, in general, those aren't all the ranges that we typically find. You can find a multitude of different ranges. You can find a range of the lower fourth, range of the middle half, or the range of the upper fourth. You can find a range of basically whatever sections you want. Okay, so we're just going to explore a little bit of that. Note, I've given you all some formulas here, but it's very easy to think about. The range of the lower fourth, you would take Q1 and subtract the minimum. Range of the middle half, you take Q3 minus Q1, which is what we did, the interquartile range. The range of the upper fourth is the maximum minus Q3. So let's look at some problems involving that. Here's an example. What is the range of the middle 50% of data? We take Q3 and Q1. Q3 is right here. Let me use a different color. Q3. And we're going to take Q1 and subtract those two. So that is 15 minus 8 is equal to 7. All right, now, what is the range of the lower fourth? Lower fourth is Q1 minus the minimum. So the minimum value is 3. We already know what Q1 was, which is 8. So 8 minus 3 is 5. All right, and then the range of the upper fourth. So the maximum value minus Q3. So we take max minus Q3. Max is about 19. Q3 is still 15, so 19 minus 15 equals 4. And that's the different types of ranges that you can expect to do for the lesson. Okay, so now you try on your own. What is the range of the middle 50%? What is the range of the lower fourth? What is the range of the upper fourth? So use what you just learned in the previous example excuse me, to subtract and get your answers for each. And then you can check behind the box to see if you did this correctly. So do that on your own. Otherwise, I'm going to continue on and show y'all how to do this. So first thing I'm going to do is actually label the minimum Q1 we don't need Q2 in these examples, so we're going to skip that. Q3 and then max. So now what is the range of the middle 50%? That's Q3 minus Q1. Q3 is about right there. So that's 31, 2, 3, 4, 5, 36. Q1 is about 14. 1, 2, 3, 4. So yeah, 36 minus 14, which I believe is 22. What is the range of the lower fourth? So that's Q1 minus the minimum value. So lower fourth, 14. Oh, Q1 is 14. The minimum looks like it's 11. So 14 minus 11 is about 3. And then what's the range of the upper fourth? So I'm going to take the max value, which is 1, 2, 3, 4, 5. So that's 45. Minus 36, which I believe is 9. Okay, and let's just check the answers. 22, 3, and 9. So we're all good. That's it for you try number 4. Okay, that's the end of 1.04 Part 1 notes. If you need anything, let me know. You have my number and email right there. Number you can text or call. After 5 p.m., typically don't answer, but if it's an important emergency math help that y'all need, then I'll see what I can do. Okay, otherwise, let me know if y'all need anything else. Take it easy, y'all.